Hello, Assalamu alaikum. This is the DSP task which was given by Sarsat, and here is the following task which were meant to perform in the Matlab, and the tasks are to record the voice in wave mono format with 16 kilohertz frequency, which is at about to length 2 seconds, and upload that in the MATLAB and plot the time domain against the amplitude and with time domain on x-axis. So we will do that in MATLAB. Here is the code of this audio, and as you can see, here is the audio read function, which is built in MATLAB to read any audio file, and fs here is the sampling frequency of that audio, and y is the and that audio is stored in y, and sound is the function in y. Ts is the sampling rate, which is 1 over sampling frequency, n is total number of samples, and t is equal to the product of total number of sample and sampling rate. And here is the plot of time versus amplitude, which was asked in the task. Here is the plot, and when we run this code here, you will get time on x-axis again versus amplitude. So this is here, and another task was to verify that the 12,000 sample is indeed occurring at 0.75 second spot. In order to do that, we will use the function uh, and .ts, which is, you can see, 0.75. That is ts. Here you can see that we have proved that 12,000, we have verified it, and which was asked in the task. And another task, another thing was asked to take DFT of this signal and plot in magnitude spectrum. Now this is the second part of our code. As you can see, here we have plotted DF, which is the frequency resolution, and F is the domain, and y FFT, this here is the function of fast Fourier transform, and the value of it fast Fourier transform is in complex exponential, which is sinusoid, and we here is magnitude, and we plot magnitude of this discrete Fourier transformer versus the frequency in hertz. Here you can see this is the plotting part, and we have already done this task, and we have to find the frequency at 3,000 and 8,000. For this I did this. I made this function to get enter the sample number, and we have entered the sample number 3,000. We will get 12,724 hertz frequency, and when we run again, at 8,000 you will get 33,930 hertz. So here I have already checked the frequencies when we enter the sample number 8000 and 3000, and our last task was to verify the spectral spacing of this. For this I have recorded another audio which is of a greater time frame, slightly higher than this audio, and the spectral spacing of this audio is 0.4241, which is of 2 seconds. And if I wait, wait when I check the spectral spacing of another audio which is of a greater time frame, here you can see the when we increase the time of the audio signal, the spectral spacing is decrease. And let it go through. Here you can see that the DF value of the spectral spacing of this audio signal is 0.2978. Hence we can be proof that when we increase the time of the signal, the spectral spacing will decrease. Spectral spacing means that when the signal is the difference of the one point of second another point of the signal, and the signal is plotted at the spacing of the 0.0.2978. This audio signal is space of 0.297, and the last previous one which was which we saw, it was 0.42 like something. Hence when we increase the time, the spectral spacing decreases. So here we done our assignment. Thank you for